Chapter 5, Lesson 1 is on solving systems of linear equations by graphing. So when we're talking about solving systems of equations, we're finding that the point where the two lines intersect. So there's going to be several ways that we're going to do that. And the first of which is by graphing both equations. So a system of linear equations is a set of two or more linear equations in the same variables. An example will be shown on the next slide. A solution of a system of linear equations in two variables is an ordered pair that is a solution of each equation in the system. The solution of a system of linear equations is the point of intersection of the graphs of the equation. So again, where those two lines will meet or cross. To solve the system of linear equations by graphing, we're going to graph the two equations given. So here, y equals x minus 1. So we know that our y-intercept is -1. And we know that our slope is +1. So we're going to go up 1 and over 1. Now we're going to draw as straight a line as possible through these 2 points. Now we can graph the second equation. So y-intercept is +3, and our slope is -1. Remember, when there's no coefficient, our coefficient is an imaginary 1. So where we have a slope of -1, we're going down 1 and over 1. When we draw a line through these points, we can see that our lines are going to cross here. This point is at the point 2, 1. So our solution to this equation, or the system of linear equations, is the point 2, 1. Now, we can do the same thing for the next two problems. With number 2, I know that these 2 points these two y-intercepts are not available on this graph. What I did instead was I made a table to get my points. So for my first equation, I'm going to try to fit this in here a little bit. I used the points, the x values 2, 3, and 4. So when I plug in 2, -5 times 2 is -10, plus 14 is 4. When I plug in 3, -5 times 3 is -15, plus 14 is -1. When I plug in 4, -5 times 4 is -20, plus 14 is -6. So I can plot these 3 points for this first equation. So 2, 4, 3, -1, and 4, -6. Now I can cross those points as best as possible with a straight line. And then I can work on my second one. So with that second one, I'm going to do the same thing. I went ahead and used the x values of 8, 6, and 4. Now I kind of took a look at these and figured out what values could I use for x and still have y-intercepts that would appear in my graph. That's how I kind of came up with these numbers. So when I plug in 8 for x, 8 minus 10 is -2, 6 minus 10 is -4, and 4 minus 10 is -6. So when I plot these points, my first one, 8, -2, so we're at 6, 7, 8, -2, and then I'm at 6, -4, and then I'm at 4, -6. So again, crossing with a straight line, I can see that my two lines cross here, which is at 4, -6. Go ahead and try the next one on your own. When we graph this third system, the first one, there is no y-intercept back here. So we know that that is at a 0 on the y-axis. We have a slope of 1. So again, straight a line as possible. And then we can graph the second equation. So y-intercept of positive 1, slope of 2, so up 2 over 1. So again, straight line as best as possible. A little hard here without being able to use a straight edge. But here our line will cross here, which is at the point -1, -1. Now looking at the next set. So we're going to see here that not all of these equations are in y-intercept form. So we're going to have to get them in that y-intercept or that slope-intercept form before we can graph them. So for this first one here, we're going to have to subtract x from each side to find that y equals -x plus 2. We can then use this to graph. So our y-intercept of 2, our slope of -1, and then we can plot our points. On this first equation here, we have a slope, our y-intercept of -7 and a slope of -4. So instead of going down 4 into the right one, we can actually go up 4 into the left one. I'm going to continue a little bit past there just to try to get me in the right area. Now here again, straight lines through those points are a little difficult on the computer, but here we have a point that crosses at -3, 5. The next one, again, we need to solve for y. So when we solve for y in the first one, we have to subtract x from each side. So we have -y equals -x plus 5. And we can divide both sides by -1 to get y equals x minus 5. So -5 on the y-intercept and a slope of +1. Then for the next one, we can add 3x to both sides. We would get y equals 3x minus 1. So again, a slope of 3. And when we put this line through here, we can see that our points cross here at -2, -7. With this last one, go ahead and give this one a try and then we will go over it together. I have started by showing that I solved for y in both equations. So here I subtracted 1/2 x from both sides to find that y equals -1/2 x minus 6. Here I started by subtracting 6x from both sides, and then I had to subsequently divide by 2, so y equals -3x plus 4. I can go ahead and graph these now. So y-intercept of -6 and a slope of -1 over 2. So going down 1 over 2. I can also go the opposite direction. I can go up 1 and to the left 2. To draw my line here. Now, my next one here, I have a y-intercept of 4 and a slope of -3. So down 3 and to the right 1. When we do this, we can see that our point of intersection is going to be slightly off the graph, but we can estimate by looking at this that we are at the x value of 4 and at the y value of -8. So our point of intersection, or the solution for this system, would be 4, -8.